Researchers at South Korea's Ulsan National Institute of Science and Technology, or UNIST, have unveiled a multifunctional 멤리스터 made from a two-dimensional semiconductor. What is a semiconductor like this, and why is the technology drawing so much interest from scientists worldwide, especially in advanced computing and memory devices? Why have semiconductors separated memory and computation? Today, most smartphones and computers operate using the von Neumann architecture. Associated with mathematician John von Neumann in the 1940s, this design keeps memory, which stores data, separate from the processor, which performs calculations. For example, when you edit a photo, the image is first retrieved from memory, processed by the processor, and then saved back to memory. As semiconductor technology advances, however, transferring data has become a greater burden than the calculations themselves. No matter how fast a processor becomes, performance cannot improve significantly if it takes too long to retrieve data. This limitation is known as the von Neumann bottleneck. In addition, moving data back and forth consumes large amounts of electricity, leading to increased heat generation and power consumption. Memristors, devices that remember electrical signals. Among the most promising answers to this challenge is the memristor. Its name combines the words memory and resistor. Unlike a conventional resistor, which cannot retain information about earlier electrical current, a memristor modifies its internal state as current flows through it and preserves that state even after the power is switched off. Because the stored information is retained without power, a memristor can function like memory. At the same time, it can perform computations using that stored state. In other words, it combines data storage and computation within a single device. Two-dimensional semiconductors make multifunctional chips possible. The key material behind this breakthrough is the two-dimensional semiconductor. While these materials are just a few atoms thick, their value extends far beyond their thickness. They allow electrical current to be controlled with exceptional precision, and different layers can be stacked to create properties that conventional semiconductors cannot easily achieve. Since the 1940s, the von Neumann architecture has shaped modern computing by keeping memory and computation separate. More than 8 decades later, that defining feature has also become one of its greatest constraints. Memristors, which process memory and computation together in a way that resembles the human brain, are considered a key stepping stone toward overcoming this challenge. Researchers are now closely watching how multifunctional semiconductors could transform the future of information processing.